Alright, this is going to be a tutorial of the how to graph on Excel and a little review of what we did in class. This is what I gave to you guys in class. I'm going to upload a new file due to a couple things. First of all, notice how the visual acuity over here, we just need the bottom number. However, this does say 2020. We just need the bottom number, so we just needed the bottom 20. Things like that needs issues. Like over here, it still has minutes when we're supposed to convert it into seconds, etc., etc. So what I had my students do in today's lab, we ended up clearing it up even more. So if you look at it, we have over here that's pretty cleared. So I'm going to use this data kind of to show you. I'm going to post this up as well. So I'm going to take down the old one and post up the new one here. So this is a little review of what we did on the day of the class. First of all, if you look at all the females over here, I have the average. And how do you calculate the average? Once again, you type in equals average and then left parentheses. Don't forget that left parentheses. And after you type in equals average left parentheses, you then want to drag all the data from that particular column that you want to take the average of. So the very first female at B3 here, all the way to the very last female at B47. And as you can see, it actually says that B3 to B47, press enter, and gives you that average. And once you have that average, instead of typing in every single column, you go to this bottom right hand corner of that cell, and notice how the big thick plus sign becomes a thin plus sign here, and then click on it and then drag across all the rows, throughout this same row, and then drag it all the way to the very last column, and then you're done. And then go to standard deviation, type in equals STDEV, left parentheses. There's only one D for this standard deviation. And then for this portion of it, drag all the data from this particular column from the very first to the very last, and then press enter. And remember, the standard deviation shows you the different how varied is the data that we got. So if you end up having very obscure numbers that are very big or very small, the standard deviation will be pretty big. But if you have all the data to be very near the average, it's going to be very small, which is actually a little better because it's a little more precise in all the different data we end up taking from all the different labs. And once again, go to the very bottom right hand of the cell and then drag it all along this row, and then let go, and it gives you the standard deviation. Do the same thing for the males, and I already did it over here, so I did the average already. Make sure when you're taking the average of the males, you're only taking the average of the males and not both the males and females. So the very last male to the very first male, you don't want to go any further than B54, because if you do go any further, you're going to be taking female data, and we don't want that. We just want the male data. So B54 all the way to B95 here. Press enter, go to the bottom right hand of the cell, drag it across, and do the same thing with the standard deviation, equals STDEV left parentheses. Once again, drag, oops, sorry, I messed up there. Drag the very last one to the very first one. Press enter, and then bottom right hand part of that cell, drag it across that row. Okay, and you'll notice that I pasted the female's average and standard deviation down here, and there's a purpose why I did that. Let me first delete that. So I pasted these two here. It just makes it a little easier to see all that data together. So I Control C or right click, copy, go down here, and then when you go down here, right click it and make sure you paste the values. It's very important that you paste the values and not just straight paste. So don't Control V it. You want to right click and paste the values. The reason why is because when you Control V it, let me just show you. If I Control V, notice how the number is totally different. It's 1.6611. The reason why it's taking the average of that equation of that average of what you posted before, and notice how it's taking all the average of this, but that's not what we want though. So make sure you paste the values, not the equation itself. And notice how if you want to just double check whether or not you did it correct, look at what you have here. This is 1.46266, and if you go all the way up here where the average of the female, same thing, 1.46266. Okay, now that we have everything here, let me first erase this. We have the average of the male and average of the female, and let's go ahead and start to make a graph of this. So go ahead and click on just say the male average for now. Insert column graph, and the best one, the most easily representable and visually representable interpretation of this data is the 2D column, just because we're comparing two different things. However, if you're comparing multiple things, you could use scatter graphs or line graphs and pie graphs, whatever best will represent the data for you. Usually, since we're comparing just males versus females, usually this 2D column will be sufficient enough. Although I think I totally messed up there, and let me delete that. Alright, let's insert column. Okay, it wants to do something I don't want it to do. Let me just copy this and right click, paste. I don't know if I'll paste it. Fine. It's not what I meant to. Come on. Okay. Copy values. Okay. Alright, let's see if this works now. Insert column 2D. Alright, whatever. It gives me this weird graph, but I don't want, we'll change it, definitely will change it. First things first. So let's go to chart layouts here. The chart layouts will show you a number of things. Think about this chart that it gave you. It doesn't show you what the y-axis is or the x-axis is, and doesn't give you a title as well. And I want all those things. So go to chart layouts on the top bar here and click on that little button that actually brings it down to give you more charts. Now I usually do this layout number 9 because it gives you the most option to type in things. So notice how it gives you the chart title here. So I'm going to be doing the density of touch between the genders, so gender differences of the touch receptor density. Okay, and this y-axis, what would you type in? This will be the amount, the averages of the in inches of the density of touch receptors. So here is touch receptor densities, and this is in inches. very important that you include the units, okay? The reason why you want to include the units is if I was to look at this, I don't know if I'm looking at 100 inches or 100 centimeters or 100 teddy bears, whatever. So it's very important that I have the units in here. Second, well, this would be gender, and we probably won't need it there, but anyway. So now you have this huge graph here. Is not what I want to show. Let me delete that there. What I want to show is, okay, so this is how you get to it. You right click on the chart area over here. Make sure you don't right click on the chart itself, but somewhere where it's blank. It'll bring up this menu here, and then you go to select data. Once you click select data, you want to first, well, we want this to be male, that's correct. However, we want to make sure that the data that we want to put in here, you can highlight it and then just click here. That's the average data that we want to actually insert it. Okay, so that's good. And let's edit this and make sure that we say that this is the males. And the series values, once again, is this average that we just calculated out. Press OK. Okay, and so now we're going to add the female. So make sure you click on Add, and let's add females. And for series values, click on that, and we'll go to the female average here. And press OK. And over here, we could edit it and just label it gender. And you'll notice that when I labeled it gender, over here it says gender here, so we could delete this gender here. But we do need this key over here that shows us that this is male and that this is females. Okay, so that's basically it, how much I want you guys to do. A couple things that I want to kind of mention is the standard deviation. Although I don't want you to calculate it out in the graph since I didn't really talk about it in class. We ran out of time. But the other thing is that it is kind of important to know, though. You'll notice that, let me actually put it on here, okay? So this is as far as you wanted to go on presenting the material. However, let me just go real quick as to how you do standard deviation. So this is more like extra. Here, not extra credit, but just extra information. So you click on the bar for the males over here. Go to this chart tools, go to layout, and notice how on the right side over here it says error bars. Click on the error bars, and since we already calculated the standard deviation, we go to more error bar options. And we want the directions to go both ways. And instead of fixed value, we go custom. And we're going to specify the value of our. So positive value, and we go to the positive standard deviation value of it there. Negative value is the same one. And then we press OK, and we close it. And notice how that's the standard deviation for that. For females, we do the exact same thing. Click on the female bar graph, go to layout, error bars, more error bar options, go to all the way to custom, specify the value, and click on the specific value that we're clicking on. Press OK, close. And you'll notice that a couple things. First of all, that the averages are pretty close together. Second of all, look how huge the standard deviation is. It's almost the same amount as the actual average is, you know. So this is how much differences in the data that we end up intaking, inputting into this. And this is really bad because it shows you how imprecise the data that we took. So it's most likely possibly due to human errors where people were inputting it, not being really diligent in what they're inputting, or not really thinking about what they're inputting, so they end up inputting ridiculous numbers. For example, like the 7 inches, like I have a hard time believing that someone who gets touched at a location will miss it by over half a foot, kind of thing. That's really bad, like being able to not perceive it that way. I mean, I'm not saying it's impossible, but it's very, very unlikely. So something like this, if you were to present this in your argument, a very good counter argument is to say, hey, notice how your standard deviation here is huge. So although the males kind of it should be the females are better at being able to have better more touch receptor density due to being able to figure out how far the distance of the so I should have really changed this title here. So it should be gender differences of touch receptor density, and instead of here touch receptor is like distance away from being touched. Remember how when someone touched us in an area and then we're supposed to point to where they're touching, that's what it should be more like. Alright, I'm really tired, so I'm going to just call it. So basically what I'm trying to say is, like, if you're making the argument that females are better at knowing how close they are from being touched, this isn't really a strong point, because you notice how the standard deviation is so big that it's not that very precise. And if the standard deviation was a lot smaller, here I'm going to just fudge it just to show you what it's ideally supposed to look like. Sorry, like that. Specify value. I'll just say 0.005. Oops. Okay. Well, okay, that's a little too much. Just do 0.5 or 0.5. Okay, notice how, like this, now the variety of data is not that various. It's all around the same area. So now I have a better precision as to all the data that was collected. And we know that over here at around 1.5 inches away from the distance from being touched at that location, locating that area, it shows that it just is a lot better results. So like something like this, I could say that it's more precise. However, notice how the difference between males and females, it's still really close together, so it's actually not that great of data to actually argue for females being better than males. And so there's other graphs that you can use to kind of help you with your argument, whether males or females. And you want to just look through all this data and figure out which ones will help you in that process. So do the same thing within the nutrition and metabolism as well. So check that out. Okay, have a good night. I'm tired. Bye.